Chapter 10, Section 3 is about friction and gravity. These are two forces that we have to work, and they can work to help us or make it a hindrance for us to move. So when we look at friction, what we're looking at is when two forces rub against each other and they place a force on each other. The two factors that affect the strength of the friction are the types of surfaces involved and how hard the surface is pushed together. Friction is when there is direct motion is opposite to each other. So when you were young kids, you probably rubbed your feet against the floor so that you could go touch somebody and give them a shock, give them a little bit of static electricity. If you rub against a smooth surface, it's easier to slide your feet. But if you rub against a floor that has texture like carpeting, it's harder to slide your feet. Now, there are three types of friction, and this is how we control how much friction we are working against to slow us down. When you have two solid surfaces, you're sliding over each other. That's known as sliding friction. That is the hardest type of friction to overcome. The next step up to make it easier is rolling friction. So if you're rolling in a chair, it's easier to move across the floor versus just walking against the floor. Or think about if you need to move a file cabinet, do you want to try and move it against the floor, sliding it? Or would you prefer to have some sort of cart and roll it across the floor? The easiest type of fluid friction to move through. Fluids include liquids or gases. So the easiest way to move, maybe when you were little, was learning how to swing in the air, or swimming through water is easier. And that is what they use. If somebody overcomes a heart attack, the first thing they have them do is walk slowly and carefully in a pool to build up their strength versus walking on the road. So if I compare and I ask a question like, put in order easiest to hardest, then I would put fluid friction as the easiest friction to overcome, then rolling friction, then sliding friction. All three of them still depend on the type of surface and how hard you're pushing each other against each other. The other kind of force we're going to look at is called gravity. And gravity is a force that pulls all objects toward the center of Earth. Free fall is when the only force acting on the object falling is gravity. So you don't have air resistance, so it's like something's in a vacuum. All the air is removed and you can just watch the object fall. The acceleration due to gravity is 9.8 meters per second squared. No matter what something is falling at, as long as there's no air resistance, it will always fall at 9.8 meters per second squared. Terminal velocity is known as the greatest speed an object reaches. So as it's getting faster and faster, meaning less and less air resistance, that terminal velocity is that greatest speed. Projectile motion is any object that is thrown horizontally. So instead of dropping something straight down, you throw it sideways. Now, air resistance is a fluid friction that's exerted on an object, forcing the object to have gravity pushing it down, but it's pushing against the air resistance that's coming up. The greater the surface area, the greater the air resistance, meaning it's harder for the object to just go super fast to the earth. All air resistance is not the same for all objects. Even if I have two objects of the same mass, now you're looking at the shape of the object. So if I take two pieces of paper, I crumple one up as a ball and the other one's a flat sheet. The one that's a flat sheet, because there's a greater surface area, will take a longer time to fall to the earth versus that object that's a ball shape, only that round bottom part has to push through the air resistance, so it moves faster. Weight is a measure of the force of gravity on an object, and weight is in newtons. Mass is a measure of how much matter is in the object. So when you stand on your bathroom scale, you're technically measuring your body mass because every object has the same amount of gravity pushing down on it, leaving you on Earth. Weight is your mass in kilograms times acceleration due to gravity. If there's less gravity, your weight is less. So on the moon, we have 1/6 of our mass or weight on Earth. We have 1/6 of our weight on Earth, even though our mass is the same in both places. So when you see the people out at the space lab, space station, they have less gravity acting on them because there's nothing out there holding them in place, so they can float through their capsule. So that's why they have to be tethered when they go out to make repairs on it. Without that tether, they would float away. The law of universal gravitation states that the force of gravity acting between all objects in the universe. Any two objects in the universe are attracted to each other. You're not going to notice objects around you are pulling on you because we're also all having the same amount of gravity holding us in place, which is a good thing. Think about it. Do we want our tables floating? Do we want our chairs floating? But because everything is being held down in place with gravity, we're not floating around. But look at our planet Earth and then look at the moon that orbits around us. Those two objects, Earth and the moon, have a gravitational pull towards each other, and it's based on the mass of each object. The greater the mass, the greater the pull. The other thing we look at is the distance. So strength of the force is going to depend on the mass, and strength of the force is also going to depend on the distance. The farther the objects are apart, the weaker the force. It's this gravitational force, though, that creates our morning and evening tides for the oceans. When the moon and the Earth are closer together, it pulls the water closer. When they're farther apart, the tide goes out. So section 3, review questions. The two factors that determine the strength of the friction force are how hard the surfaces push against each other and the types of surfaces that push against each other. Number 2, mass is how much matter is in the object, while weight is looking at that amount of mass and the gravity acting on an object. Okay? This is really big, so think, and I want you to think about comparing the person's mass on Earth versus a person's mass out in space. When there's less gravity, you're going to weigh less because you have less gravity acting on you, not because there's less mass. Number 3 wanted to know what the law of universal gravitation is, and that's that law that says there's a force acting on every object using gravity, and it's why you're sitting in your seat instead of floating through a room, and the force is proportional to the distance between the two objects. Closer together, more force. Farther apart, less force. Then question 4 wanted to know if when the squirrel drops the nut over a cliff, can we determine the velocity? And we can using acceleration formula, just like we did just in chapter 9. You rearrange to find the final velocity where acceleration is multiplied by the time, and then the initial velocity was 29.4 meters per second, and then the final one was 98 meters per second. And if you noticed, that squirrel dropping the nut over a cliff was used in a movie. Somebody had learned something in science class.